All right, today we'll be working on application of first derivative. So we are going to look at the ways we can use the first derivative to solve the real world problem. Following are some of the important applications of first derivative of a function. So how we are going to use the first derivative in this class? Here we have the three situations. The first one is we are going to use the first derivative to determine the interval on which the function is increasing, decreasing, or remain constant. So first derivative will help you to check whether the function is increasing, decreasing, or it remains constant on certain interval. It will help you to find whether the function is increasing or decreasing on certain interval. The function will be increasing if the first derivative, if the first derivative is positive, greater than 0. If the first derivative is positive, the function is increasing. If the first derivative is negative, the function is decreasing. If the first derivative is negative, the function is decreasing. And the function will remain constant if the first derivative is equal to 0. So we use the first derivative to determine whether the function is increasing, decreasing, or it will remain constant on a given interval. Second application, determine the critical points on the graph of a function. So on the graph of the function, we'll be able to determine the critical points. When we say critical points, these are the points on the graph at which the first derivative of the function is 0 or undefined. So when we say critical points, these are the points, at which the first derivative of the function is either 0 or undefined. So we are going to determine that using first derivative. The point where the first derivative is 0 or first derivative is undefined, we call them critical point. And the third and very important application of first derivative is it will help you to compute the maximum and minimum value of a function on a given interval. So on a given interval, if you want to find the maximum or minimum value, we use the first derivative. So now what we are going to do is we are going to solve the problem where we determine whether the function is increasing, decreasing, or constant. Second, we are going to find the critical points on the graph of the function. And then the third one is we are going to find the maximum and minimum value of the function on a given interval using the first derivative. Example, determine the intervals on which the graph of the function f of x equal to 1/3 x cubed plus half x squared minus 6x plus 5 is increasing and decreasing. So we have to find the interval on which the function is increasing and decreasing. We are looking for the interval. We are looking for the interval on which the function is increasing and where it is decreasing. So what we are going to do is, in order to determine whether the function is increasing or decreasing, we need to find the first derivative. And if the first derivative is increasing, I mean positive, it is increasing. And if the first derivative is negative, it is decreasing. So let's begin with the function. Here, my function is f of x is equal to 1/3 x cubed plus half x squared minus 6x plus 5. That is my function. Now, if I want to find the first derivative, we write f prime x, that is equal to 1/3 is a constant. We'll keep as it is. In order to find the derivative of x cubed, we use the power rule. So 3 will come down and we decrease the power by 1. 3 will come down, decrease the power by 1. So 3x squared. Again, half is a constant. So constant multiple, we'll keep that half there. Derivative of x squared using the power rule. We bring that power down and decrease the power by 1. So that is 2x. And then minus 6 is a constant multiple. Derivative of x with respect to x is 1. So it is 6 times 1. That's what we can write there. And then the derivative of 5, that is derivative of constant, is 0. So if you want, you can add 0 there. So my first derivative is, you can see here, it is 3 or 1/3 of 3, which is 1 times x squared, which is x squared, then plus half of 2 is 1, so that is 1x minus 6. So we get our first derivative. First derivative is x squared plus x minus 6. Now, if you look at this function here, this function is a cubic function. So the domain of the function, if you remember from your college algebra, the domain of the function is from negative infinity up to infinity. The function is defined for everything from negative infinity up to positive infinity. Now, we need to find where this function is positive, that is increasing, where the derivative is positive, and where this first derivative is negative, that is decreasing. So before that, what I'm going to do is, I am going to find something called the critical point. Critical point. Critical point is the point where the first derivative is 0. So for the critical point, we set the first derivative to 0. X squared plus x minus 6 equal to 0. Now you can solve this equation by factoring. If you factor, it will be x plus 3 multiplied to x minus 2 equal to 0. So we get x equal to negative 3, because when x plus 3 equal to 0, x equal to negative 3. Or the second value is x equal to 2, because we have x minus 2 equal to 0, meaning of that is x equal to 2. So at these 2 points, x equal to negative 3, x equal to negative 3, and x equal to 2, the derivative is 0. Here the derivative is 0. Here the derivative is 0. So here we have derivative 0. Here we have derivative 0. Now we have 3 intervals. Here is one interval. Here is the second interval. Here is the third interval. So we have to check whether the function is increasing or decreasing here, increasing or decreasing here, and increasing or decreasing here. And we already know that if the function is increasing, the first derivative will be positive. If the function is decreasing, the first derivative will be negative. So we are going to test each of these intervals. So let's do that testing. We have to test each of the interval to see whether the function is increasing or decreasing. So let's check the intervals or test the intervals. Let's do testing. The first one is when x equal to, okay, here we have a negative 3. Now you have to plug in something from this interval. From here you have to plug in something. Here is negative 3, so the easiest one will be plug in negative 4. Your f prime x, your first derivative. So what I'm doing is I'm selecting a value from here and I'm finding the value of the first derivative, okay, first derivative in that interval. So if you plug in 4 to this equation here, if you plug in 4 squared is 16, 16 plus 4, I'm plugging in, hold on, I am plugging in negative 4. So negative 4 squared, 16, that's fine. Here I'm plugging in negative 4. So that is negative 4 minus 6. Now if you look at the result, 16 minus 4 minus 6, that is you are subtracting a 10, which will give you a positive 6. Positive 6, that is greater than 0. So meaning of that is your first derivative is positive here in this interval. In this interval, the first derivative is positive. Meaning of that is the function is increasing here. Now let's find out what is going on in this interval. So in this interval, the best number that you can plug in is 0. So let's try to plug in 0. When x equal to 0, let's find out what happens. Okay, when x equal to 0, your first derivative will be, if you plug in 0 to the first derivative, we have 0 squared, 0 plus 0 minus 6. 0 plus 0 minus 6, which is equal to negative 6. Negative 6 means less than 0. So your first derivative is negative. Meaning of that is in this interval, the function is decreasing. In that interval, the function is decreasing. Now we have to check here in this interval from 2 up to infinity. The best number that you can plug in is 3. Let's try to plug in 3. So when x is equal to 3, your first derivative when x equal to 3 is equal to, if you plug in 3 here, 3 squared is 9 plus 3, 9 plus 3, 12 minus 6. 12 minus 6 is equal to 6, which is greater than 0 or positive. Positive. So what we have seen here is the function is increasing in this interval and also in that interval, and it is decreasing on this interval. So when we write the answer, we write it like this. So f of x, the function is increasing on this interval here. That's from negative infinity up to negative 3. Negative infinity up to negative 3. And on this interval from 2 up to infinity. On the interval from 2 up to infinity. So that's where the function is increasing. And the function is decreasing. Function is decreasing on this interval here. There is a negative. First derivative is negative. It's decreasing there from negative 3 up to 2. Decreasing on the interval from negative 3 up to 2. So this is how we can use the first derivative test to determine whether the function is increasing or decreasing. Example, find the critical point on the graph of the function y equal to x over e to the x and answer the following question. So first, we have to find the critical point. We have to find the critical point. And you know that the critical point is a point on the graph of a function where the first derivative is equal to 0. It's a point on the graph of the function where the first derivative is equal to 0. So first, we are going to find the critical point. In order to find the critical point, we have to find the derivative and set it equal to 0. So here, what we have is y equal to, or f of x equal to, x over e to the x. You can see there is x over e to the x, which can be written as x times e to the negative x. It is the same thing. If you write this in the numerator, the exponent will be negative. Now the advantage of writing like this is now it is in the form of a product and you can use the product rule. If you want to use it like this, you have to use the quotient rule. So it's up to you how you want to do it. I want to write like this and then use the product rule. Now the derivative is equal to, if I use the product rule, it says first function x multiplied to the derivative of the second plus second function e to the negative x multiplied with the derivative of the first. So my first derivative will be equal to x multiplied to derivative of e to the negative x is negative e to the negative x, then plus e to the negative x multiplied to 1. So this implies my first derivative is equal to, you can see in both terms here, e to the negative x is common. So we can factor that out, e to the negative x out. And when you factor e to the negative x out, you have 1 here, and here you have a negative x. So 1 minus x. So we can write this as f prime x equal to 1 minus x over e to the x. If you take that to the denominator, it will be positive. So that is the first derivative. We got the first derivative. Now for the critical point, we have to set it equal to 0 and find the value of x. Now we are asked to find the critical point. So we set the first derivative to 0, or we have to see where the first derivative is undefined. In this case, because you have e to the x in the denominator, value of e to the x is always positive. Okay, value of e to the x is always positive. So there is no way that it will be undefined. So the only case that we have is the first derivative is equal to 0. So if first derivative is 0, if first derivative is equal to 0, then what I'm saying is 1 minus x is equal to 0. Because for the fraction, for this fraction to be 0, the numerator must be 0. For the fraction to be undefined, the denominator must be 0. But here I am looking for this fraction or the first derivative to be 0. And this fraction will be 0 when the numerator is 0, when 1 minus x equal to 0. So this implies x equal to 1. So this implies x equal to 1. So x equal to 1 is the critical point. So my answer for this is, so x equal to 1 is the critical point. X equal to 1 is the critical point. So we have the function, which is given as x over e to the x. We found the derivative, 1 minus x over e to the x, and we got the critical point, x equal to 1. Now in part A, we are asked to state the interval on which the function is increasing and the interval on which the function is decreasing. Meaning of that is we have to find where the function is increasing and decreasing, that is where the first derivative is positive, and the interval on which the first derivative is negative. Because our function is x over e to the x, the domain of the function is from negative infinity up to infinity. So the domain of the function is from negative infinity up to infinity. The critical point is x equal to 1. So at x equal to 1, the derivative is 0. So now we divide the domain into two intervals. This is the first interval, this is the second interval. Now we have to check in each interval, like in this interval, whether the function is increasing or decreasing, and in this interval, whether the function is increasing or decreasing. So what we are going to do is, we are going to test the interval. So let's do that testing. Testing. When x equal to, here is 1, so you have to plug in a number which is below 1, so you can plug in 0. When x equal to 0, your first derivative at 0, first derivative at 0, this is my first derivative. At 0, it will be 1 minus 0 over e to the 0. 1 minus 0 is 1, e to the 0 is 1. 1 over 1 is 1, which is greater than 0 or positive. So here, in this interval, the first derivative is positive. Meaning of that is, the function is increasing on this interval. Now we have to check on this second interval. So for this interval, you can plug in x equal to any value from this interval. I'm going to plug in x equal to 2. When x equal to 2, the first derivative at 2 will be, we are plugging in here, so it will be 1 minus 2. 1 minus 2 divided by e to the 2. So e to the 2 is a positive number. 1 minus 2 is negative 1 over e squared. E squared is positive. So 1 divided by positive number, that's positive with a negative in front. So the result is negative, less than 0. So that is minus there. So meaning of that is the function is increasing on the first interval and decreasing on the second. So my answer will be, so f of x is increasing, f of x is increasing on the interval from negative infinity up to 1. From the interval from negative infinity up to 1. And f of x is decreasing, f of x is decreasing on the interval from 1 through infinity. On the interval from 1 up to infinity. So that's how we can find the interval where the function is increasing and where it is decreasing. You can always verify your work using your graphing calculator or by sketching the graph of the function. Let me show you in this case. If I want to sketch the graph of that function, which is given there, that is x over e to the x. Let me draw the x's first. Okay, this is my x-axis, this is y-axis. If you want to sketch the graph of the function x over e to the x, your graph will look something like this. I'm drawing here. Hold on, let me make it a little beautiful. You can verify this using your calculator. This is the graph of the function y equal to x over e to the x, x over e to the x. And then this is the point x equal to 1. This is the point x equal to 1. Here, the derivative is 0. That is the critical point. Meaning of that is, if the first derivative is 0, the slope of the tangent line is 0. So if you try to draw the tangent line there, the tangent line is horizontal. That is the meaning of that. Now, if you analyze the graph properly, you can see for all values of x, which is less than 1, that is from negative infinity up to 1, this graph is going down. If you look from right to left. But what we do is we always check from left to right. If you go from left to right, check here. When you go from negative infinity up to 1, that's from right, that's from left to right, you can see that the function is going up, the function is increasing. That's the meaning of that. Whereas after x equal to 1 all the way up to infinity, from x equal to 1 all the way up to infinity, the graph is going down, it is decreasing, you can see there. So from negative infinity up to 1, the graph of the function is increasing when you go from left to right. And then from x equal to 1 up to infinity, the graph is decreasing. When you go from 1 up to infinity, the graph is decreasing. So that is the interval where the function is decreasing. So that is the end of part A. Now in part B, we have to find, let's see what we have to find. For what value of x on the graph of the function, the tangent line is horizontal. So on the graph of this function, where is the tangent line horizontal? Tangent line is horizontal when the first derivative is 0. That is the critical point. First derivative is 0 is critical point. And our critical point is x equal to 1. That means at x equal to 1, the tangent line is horizontal or the first derivative is 0. Or if you look at this line here, you can see at x equal to 1, the derivative is 0. So that is where you have the horizontal tangent line. So we can say the tangent line is horizontal at x equal to 1. So that is the end of this example. Example, find the maximum and minimum value of the function, which is given here on the interval -3 up to 4. We are not looking at the entire domain, but we are looking from -3 up to 4. In this interval, where is the function, or where the function has a maximum value and where it has minimum value? Let's talk about that. In order to find the maximum or minimum value, we can use the first derivative. That's what we are going to do here. So what we are going to do is, first we are going to find the first derivative of this function. So let's begin with that function. Here my function is f of x is equal to x to the 2/3 multiplied to 4 minus x squared. You can multiply or you can distribute this x to the 2/3 first, so that it will be a little simple. If I distribute x to the 2/3 multiplied to 4 is 4x to the 2/3, and then minus x to the 2/3, and here we have x squared. So we are multiplying those two. Whenever we are multiplying, we add the exponent. So 2/3 plus 2 is 8/3. 8/3. Now let's find the derivative. First derivative will be equal to, So here 4 is a constant multiple, so it is 4 times. For this one we use the power rule. We bring the power down 2/3 and we reduce the power by 1. 2/3 minus 1 is negative 1/3. 2/3 minus 1, we reduce the power by 1. So 2/3 minus 1 is negative 1/3. Now here we use the power rule, so that 8/3 will come in front, minus 8/3 will come in front, and then we reduce the power by 1. So 8/3 minus 1 is 5/3. 8/3 minus 1 is 5/3. Now let's simplify and make this little beautiful. Now if we multiply 4 with 2/3, it will be 8/3. So this is equal to 8 over 3. And this one, x to the negative 1/3 is there. If I take it to the denominator, it will be x to the positive 1/3. And then minus, here I have 8/3 x to the 5/3. I'm going to write as it is for now. 8/3 x to the 5/3. Now what I'm going to do is, in order to combine these two, we must have a common denominator. Here we have 3x to the 1/3, but here I only have a 3. So in order to make a common denominator, I have to multiply both numerator and denominator of the second term by x to the 1/3. So I'm going to do that. Multiply the numerator by x to the 1/3 and denominator by x to the 1/3. This is how the simplification will be easy, because now in the denominator, you have a common factor. You have a common denominator, 3x to the 1/3, 3x to the 1/3. Common denominator, 3x to the 1/3. That is the common denominator. And once you have the common denominator, in the numerator, in both of them, you have an 8. If you want, you can take that 8 out. That's okay. And when you take this 8 out here, you are left with 1 minus. And here, see, this 8 is already taken out. We have x raised to 5/3 multiplied to x raised to 1/3. When you multiply, the power will be added. It will be 5 plus 1, 6/3 or 2. So it will be x raised to 2. So what we have done so far is, we have this function given. We found the first derivative. That is the first derivative of this function. So first step, we find the derivative. Now second step, we are going to find the critical points. So let's see how we can find the critical points. Critical points. And if you remember the definition of critical points, these are the points where the first derivative is undefined or 0. So here, the first derivative, f of x, is 0. The first derivative is 0. When I say first derivative, this quantity, the first derivative is 0 when the numerator is 0. Okay, the fraction will be 0 when the numerator will be 0. That is when 8 times 1 minus x squared is equal to 0, which is same as 1 minus x squared equal to 0, because 8 multiplied to how much is 0? 8 multiplied to 0 is 0. So this must be 0. Now, if you try to solve it, you add x squared on both sides, so you'll get x squared equal to 1. Meaning of that is x is positive and negative 1. So you get two values there, x equal to plus 1 and x equal to minus 1. That is, or these two values are the critical values when the first derivative is 0. Now the second case is, the first derivative is undefined. The first derivative is undefined when, so this is my first derivative. It's a fraction. It will be undefined when the denominator is 0. That is when 3 times x to the 1/3 is equal to 0. If you divide on both sides by 3, it will be x to the 1/3 equal to 0. And if you take cube root on both sides, then you get x equal to 0. So we get three critical points. The critical points are x equal to -1, 0, and +1. So we can write, critical points are x equal to 0, x equal to 1, and x equal to -1. So we got the first derivative. Using the first derivative, we got the critical points. We want to determine the maximum and minimum value. Now in next step, we have to determine the interval on which this function is increasing or decreasing. And after that, we'll be able to tell where we have maximum and where we have the minimum. So this is what we have so far. We have the function, we have the derivative, and we have the critical points. Now, if you look at this function, this is defined for all values of x. So meaning of that is the domain of the function is from -infinity up to infinity. The domain of the function is from -infinity up to infinity. But if you look at the question, we are not interested in everything. We want to look at the function from -3 up to 4. So instead of going from -infinity up to infinity, in this case, we want to go from -3 up to 4. We want to go from -3 up to 4. So we are going to redraw this, and we want to consider from -3 up to 4. So that's where we are studying this function for maximum and minimum value. We already have the critical values, x equal to -1. That is, at -1, the derivative is 0. Similarly, at x equal to 0, the derivative is 0. And also at x equal to 1, the derivative is 0. Now, by doing this, we have 1, 2, 3, 4 intervals. So what we are going to do is, in each of these intervals, we want to check whether the function is increasing or decreasing. So we are going to do that testing. Let's do some testing here. So in order to perform the testing, what we are going to do is, we are going to plug in the values. We are going to plug in the values from each interval. So here, if I plug in x equal to, here is 3, here is -1, so I can plug in -2. So when x equal to -2, if you plug in -2 to the derivative, then the first derivative at -2 is equal to, it will be 8 multiplied to 1 minus -2 squared is 4, divided by, in the denominator, 3 times x is -2 raised to 1/3. So -2 raised to 1/3, that's a negative value, multiplied to a 3, that is negative in the denominator. And in the numerator, 1 minus 4 is a negative, multiplied to 8, that's also negative. So negative over negative is positive. So the overall result is positive. So here, in the first interval, the function is increasing because you have a positive value. The function is increasing on the first interval. It is increasing there. Now let's see what is going on in the second interval. Over here, between 0 and -1, we can plug in -12. When x equal to -12, the first derivative at -12 is equal to 8 times, let's plug in -12, so 1 minus -12 squared is 1/4, and then 3 times -12 raised to 1/3. Now if you look at it carefully, in the numerator, 1 minus 1/4 is 3/4, which is positive, multiplied to 8. The numerator is positive, whereas the denominator, -1/2 raised to 3, that's a negative value. So positive divided by negative is negative. So we can say it is less than 0. So meaning of that is, here the function is decreasing because the first derivative is negative. Function is decreasing there. Now let's check 2 more intervals. Here you have to plug in half. When x equal to half, when x is equal to half, then the first derivative at half is, if you plug in half, it will be 8 multiplied to 1 minus 1/4, because half is squared is 1/4, over 3 times half is squared. Now, 1 minus 1/4, 3/4, that is positive. Positive number multiplied to 8. Positive in the numerator. And in the denominator, 3 times half is squared, that's also positive. Positive divided by positive is positive, greater than 0. Meaning of that is the function is increasing in this interval. So I can write a plus there because this first derivative is positive. The function is increasing there. Now in the last interval from 1 up to 4, I can plug in 3. Let's plug in 3. When x equal to 3, the first derivative will be equal to 8 times 1 minus, 8 times 1 minus 3 squared is 9. And then 3 times x raised to 1/3, that is 3 raised to 1/3, because our power is 1/3. So everywhere we raise the power 1/3. So there also it was 1/3. Okay, now over here the denominator is positive because positive raised to 1/3 is positive. When you multiply with 3, that will be positive. But in the numerator you have 1 minus 9, which will be negative. Negative multiplied to positive is negative. Negative in the numerator, positive in the denominator. Negative over positive, the result is negative or less than 0. So the first derivative is negative in this interval. So meaning of that is the function is decreasing over there. So what we have done so far is using the test on the intervals, we determine where the function is increasing and where it is decreasing. So now what we know is in this interval from -3 up to 1, the function is increasing. It's going up. That is the meaning of increasing. I'm drawing that increasing. The derivative becomes 0. That is, you will have a horizontal tangent line there. And in this interval, the function will be decreasing. So after it reaches that top by increasing, it will come down like this. So function is increasing and then decreasing. So if the function is increasing and then decreasing, you can see that you have a maximum value there. So there is a maximum value. The function has a maximum value at x equal to 1. Similarly, if you look at this interval, in the second interval, the function is decreasing like this, or I can again draw like this. The function is decreasing. In this interval, the function is decreasing. And after this, when the derivative becomes 0, after that, it is increasing. Increasing means it's going up now. So meaning of that is, first it is coming down and then it's going up. That means here you have a minimum value. You have a minimum value. You have a minimum value at x equal to 0. Similarly, if you want to look here in this interval, the function is first increasing up to x equal to 1, and after that it is decreasing. After that it is decreasing. So first increasing and then decreasing. That means you will have a maximum value there and it is started decreasing. So you have the maximum value there. So f of x is maximum at x equal to -1 and x equal to +1. So we can write f of x is maximum at x equal to +1 and -1. At +1 and -1, the function is maximum. And it is minimum at x equal to 0. F of x is minimum at x equal to 0. So we know where the function is maximum and where it is minimum. Now the maximum value will be, let's see, f max, that is the maximum value of the function, will have the maximum value at -1 and +1. So if you plug in -1 here, or you can plug in both if you want, let's do negative or +1 raised to 2/3, raised to 2/3, multiply to 1 minus your x is plus or minus 1 squared. This is equal to, if you look at this carefully, you'll be able to find the value. That is the maximum value. We are looking for the maximum value. Now, this is not 1 minus. I think it's 4 minus. Yes, it is 4 minus. Over here, plus or minus 1, it can be positive 1 or negative 1. And if you put that in parentheses and raise to power 2/3, you can try that in calculator. This is always 1. And inside the parenthesis, plus or minus 1 is squared. That's also 1. So here we have 4 minus 1, which is 3, multiplied to 1, that is 3. So the maximum value of the function is 3. That is the meaning of that. The maximum value of the function is 3. And the minimum value, we obtain the minimum value by plugging in 0. So if you plug in 0 here, it will be 0 raised to 2/3. 0 raised to 2/3. Then you have 4 minus, okay, 4 minus 0 squared. 4 minus 0 squared. So if you try to simplify this, 0 squared is 0. So 4 minus 0 is 4. 4 multiplied to 0 raised to 2/3 is 0. So 4 multiplied to 0 is 0. So the minimum value is 0. So hence you can say that the maximum value of the function is 3. So the graph will not go above 3. And the minimum value of the function is 0. Meaning of that is the graph will not go below 0 in that interval from -3 up to 4. So this is how we can use first derivative to find the maximum or minimum value of a function. Example, a piece of cardboard measuring 8 centimeter by 12 centimeter is formed into an open top box by cutting the squares with the side length x from each corner and folding up the sides. Okay, they are saying something there which looks interesting. What they said is there is a piece of cardboard measuring 8 by 12. So let me draw that first. Suppose that is the cardboard which measures 8 by 12, that is 8 centimeter width. Is it a centimeter? Yes. And 12 centimeter long. So length is 12, width is 8. Now what is done is, this piece of cardboard is formed into an open top box by cutting the squares side length x from each corner. So from each corner they are cutting a square. Here they are cutting a square x by x. Here they are cutting the other square which is also x by x. In this corner also they are cutting the square x by x, and also in the fourth corner they are cutting the square x by x. They are cutting and removing this square. They are throwing this square out. 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 And then they are folding along this line. They are folding here along that. So when they fold along that, you can see that this green dotted line is the base of the box. This one, it will come up. This will also come up. This will come up. This will come up. So you'll form an open top box. And your box may look like this. Let me draw it here. Your box may look something like this. Let me draw. The top of the box is open, and we form a box like this. Now, if you look at the base of the box, the length of the box is from here up to here. The total length was 12. From this 12, here the x is removed. Here the x is removed. So the length from here all the way up to here was 12. From 12, x and x, 2x is removed. So this is 12 minus 2x. 12 minus 2x centimeter long. Similarly, the width of the box, if you want to look at this width of the box, you can see from here all the way up to here, it was 8. From 8, x is removed here, x is removed here. So this green, which goes here, is 8 minus 12. So this width of the box, this is 8 minus 2x. If I say something else, it is 8 minus 2x. Okay, 8 minus 2x is the width. And the height, you are folding this as this piece. You are folding this piece. You are folding this piece. You are folding this piece. Each of them has a height of x. So the height of the box is x. So that is the meaning of that first sentence. A piece of cardboard measuring 8 centimeter by 12 centimeter is formed into an open top box by cutting the squares with the side length x from each corner and folding up the sides. Now in part A, we are asked to find a formula for the volume of the box in terms of x. So here 12 minus 2x is the length, width is 8 minus 2x, and the height is x. So the volume will be length times width times height. So we can easily write the formula for the volume. So for part A, volume, we can write V as the function of x is equal to length, it is 12 minus 2x, width is 8 minus 2x, and the height is x. So that is the formula for the volume of the box. If we multiply, if we FOIL these two and then multiply by x, then we get 4x cubed after multiplying, 4x cubed minus 40x squared plus 96x. So that is the exact formula for the volume of the box. And note one thing, the value of the x, because the width of the box is 8, okay, width of the cardboard is 8, you cannot cut a square which is 4 centimeter or more. That means the value of x here is only from 0 up to 4. X belongs to the interval from 0 through 4. That means I can say that the domain here is from 0 through 4. And this is the formula for the volume of the box. Okay, part B, we have to find the value of x that will maximize the volume of the box. So the volume will be maximum at the critical point. So in order to find the critical point, it's the point where the first derivative is 0 or undefined. So in this case, there is no way that it will be undefined because the denominator is 1. So the only possibility is the first derivative can be 0. So what I'm going to do is I'm going to find the first derivative and set it equal to 0. Now the first derivative of the function is equal to, if we use the power rule here, this 3 will come down. So 4 times 3 will be 12. X cubed minus, when you use the power rule here, that 2 will come down. No, x is squared because we reduce the power by 1. Then minus, if you bring that 2 down, it will be 80 and reduce the power by 1 plus 96 times the derivative of x is 1. So it is 96. So that's my first derivative. If I set this equal to 0, if the first derivative is equal to 0, then I can write 12x squared minus 80x plus 96 equal to 0. We can divide throughout by 4 to make it a little simple. So if I divide this by 4, 4 times 3 is 12, 3x squared. 4 times 20 is 80. And then plus 4 times 24 is equal to 0. 4 times 24 is 96. So if I divide throughout by 4, that is the equation. Now we need to solve this equation. We need to solve this quadratic equation and find the value of x. Now, in order to solve this quadratic equation, factoring is not possible. So I'm going to use the quadratic formula. If you remember the quadratic formula, it is x equal to, okay, look at the equation carefully. This is like ax squared bx, in place of b, I have negative 20, and then c equal to 0. So our quadratic formula says x equal to negative b. Negative of negative 20 is positive 20, plus or minus the square root of b squared. Negative 20 squared is 400. B squared minus 4ac. 4 times a is 3. C is 24. Divided by 2a. 2 times a is 3. 2 times 3 is 6. So you'll get x equal to 20 plus or minus, okay, 3 times 4, 4 times 3 or 3 times 4, that's 12. 12 times 24 is 288. 400 minus 288 is 172. Square root of 172 divided by 6. So x is equal to, we are getting two values here. So what you have to do is we have to type this in our calculator. 20, we can do plus square root of 172 all divided by 6, and 20 minus square root of 172 divided by 6. We'll get two values of x. One of them is 5.1 and the other one is 1.6. So those are the critical values, x equal to 5.1 or x equal to 1.6. But this value 5.1 is not possible because it is outside the domain. Our domain is from 0 through 4. So x equal to 1.5 is outside the domain. This value is outside of domain. That is outside of domain. So the only valid value is x equal to 1.6. Okay, so what we have is our domain is from 0 through 4. Our domain is from 0 up to 4. And we got the critical point, that is 1.6. Critical point is 1.6. Meaning of that is at x equal to 1.6, the derivative is 0. Now we have to check what is here and what is here. Is it positive here or negative? And here we have to check whether it's positive or negative, the first derivative. So when x is equal to, this is 1.6, now you can plug in 1. If you plug in x equal to 1, then the first derivative at 1, I can write first derivative at 1 is equal to, I need to plug in 1 into this first derivative. So it will be 12 minus 80. I'm plugging in 1, so 12 minus 80 plus 96. So here, 96 minus 80, that's a positive value, plus 12, that's also positive. So the overall result is positive. Meaning of that is the function is increasing on this interval, increasing on the interval from 0 through 1.6. Let's see what is happening here on this interval. That's when x equal to, I can plug in 2. So if I plug in x equal to 2, when x is equal to 2, the first derivative will be equal to, okay, if I plug in 2, so this will be the first derivative at 2, which is equal to, by plugging in 2, 2 squared is 4, 4 times 12 is 48. 48 minus 80 times 2, 160, plus 96. Now, if you try to simplify this one, you can quickly add these positive values, which is 48 and 96. So 48 plus 96 is equal to 144. 144 minus 160 is a negative value because it is negative 16. So it is less than 0 or negative value. So here in the second interval, the first derivative is negative. First derivative is negative. So what is going on here is in this interval, the function is increasing. Function is increasing, positive derivative. And then we have a negative derivative, meaning of that is the function is decreasing. So at x equal to 1.6, the function has the maximum value. Function has maximum value. So now we can answer our question. The question was find the value of x that will maximize the volume of the box. So we can say the volume of the box is maximum at x equal to 1.6. So let me write that. So volume is maximum when x is equal to 1.6 centimeter. So that is our part B. Now in part C, we have to find the dimensions and the volume of the box with maximum volume. So we have the value of x, so the dimension will be 12 minus 2x, 8 minus 2x, and then x. So we can say for part C, we can write dimension of box with maximum volume, hold on, is, okay, your first side is 12 minus 2x and x is 1.6. So if you try that in your calculator, 12 minus 2 times 1.6, that should be 8.8. So that is 8.8 centimeter by, now if you want to look at the width of the box, you can clearly see the width of the box is 8 minus 2x. So it will be 8 minus 2 times 1.6, which is equal to 4.8 centimeter. 4.8 centimeter by the height. The height of the box is x, which is 1.6. 1.6 centimeter. So these are the dimensions of the box. Okay, the dimensions of the box, that is 8.8 centimeter by 4.8 centimeter by 16 centimeter. And we are also asked to find, if you look at the question, we are asked to find the dimensions of the box and also the volume of the box. So the volume will be, that is the maximum volume, is equal to find the volume, we multiply length, width, and height. So it will be 8.8 multiplied to 4.8 multiplied to 1.6. So we can multiply this in our calculator. The result must be 67.584 centimeter cube. So that is the maximum volume of the box that can be produced by cutting the corners and folding it up. Example, an airline states that the sum of length, width, and height of a baggage should not exceed 64 inches. Find the dimension of a square-based baggage with maximum volume. So here we are looking for a baggage where the length, width, and height, if you add these three, it should not be more than 64. So the maximum you want is 64 inches. So let's draw a box first, which is the baggage, in fact. So I'm drawing a baggage over here with certain length, width, and height. Okay, that is my box. And we have to find the dimensions of square-based, meaning of that is the base of the box must be square. That is, if the length is x, inches, the width must be x inches. That is the square-based box. Height, I don't know what it is, so let's consider y inches as the height. So let's write, let the dimension be x inches by x inches by y inches. Meaning of that is, length is x inches, width is x inches, and height is y inches. Now, what they have given is the maximum sum of the length, width, and height can be 64. It should not be more than that. So if you add x plus x and y, that will be 2x plus y is equal to 64, which is same as if you want to find the value of y from here, then y is equal to 64 minus 2x. If you subtract 2x on both sides, you'll get the value of y, and y is equal to 64 minus 2x. So we are talking about the maximum volume. So the formula for volume will be, but the volume, which is written in terms of x, is equal to, if you remember the formula for the volume, it is length multiplied to width multiplied to height. So if I multiply it is x times x, x squared multiplied to y, which is x squared y. Or the volume is equal to x squared multiplied to value of y is 64 minus 2x. 64 minus 2x. So if I simplify this, the formula for the volume will be, okay, 2x, negative 2x multiplied to x squared is negative 2x squared. Then plus 64 multiplied to x squared is 64x squared. This one is negative 2x multiplied to x squared, negative 2x cubed. And then 64 times x squared, 64x squared. So this is the formula for the volume of the box. Now what you have to do is we have to maximize this volume function, because we are asked to find the dimension of the box when the volume is maximum. So far we have the volume, which is equal to negative 2x cubed plus 64x squared. And we know that the length cannot be 0 or the length cannot be 64. So your length or x must be between 0 and 64. In order to maximize this, first we are going to find the first derivative. So the first derivative is equal to negative. If I use the power rule, this 2 will come in front. 3 will come in front. So 3 times 2 will be 6. And reduce the power by 1. So 6x squared. Plus, if I move that power down, then it will be 128. And you reduce the power by 1. So it will be 128x. So we got the derivative using the power rule. In order to find the maximum or minimum value, we need the critical values. And the critical values are the values where the first derivative is 0 or undefined. This is defined for all values of x. So the only possibility is where this is equal to 0. So if the volume, the derivative of the volume is 0, then you can say negative 6x squared plus 128x is equal to 0. So what we can do, we can factor and solve it. So the common factor here is negative 2x. So let me factor that out. Negative 2x out. So it will be 3x, then minus 64 equal to 0. Okay, if you factor out negative 2x times 3x is 6x squared, and negative 2x multiplied to negative 64 is positive 128x. Now, the meaning of this one is negative 2x equal to 0 or x equal to 0. And the other possibility is 3x minus 64 is equal to 0. Meaning of that is x is equal to 64 over 3. Now you can clearly see our domain is from 0 up to 64. It does not include 0. So this one, x equal to 0, is outside the domain, not included in the domain. So you can say this is not included in the domain. So that is not possible. So only possibility is x equal to 64 divided by 3. You can check the value approximately how much is 64 divided by 3. If you divide that, it should be 21.3. So x is 21.3 approximately. Now, after we get the value of x, that is 64 over 3, we have to check whether we have maximum value over there or not. So for that, we draw the number line for the domain, and domain is from 0 up to 64. 0 not included, 64 not included. We got the critical point, 64 over 3, or you can also write 21.3, 64 over 3, or 21.3. Now we can clearly see that we divided the domain into two intervals. So we have to check whether the function is increasing here or decreasing, and here whether it is increasing or decreasing. So we are going to plug in the values. Let's plug in the values when x equal to, okay, over here we have 21.3, so you can plug in 20. If you plug in 20, let's see what you get. If you plug in 20, then the derivative of the volume will be, you are plugging in 20 into the derivative function. Here is the derivative. So it will be negative 6 times 20 squared, negative 6 times 20 squared plus 128 times 20. Now you can simplify that in your calculator. So the way you type is negative 6, and then in the parenthesis, you'll type 20, square that, and then plus 128, and inside the parenthesis, you'll type 20. And if you perform that calculation, you'll see that the result is 160, which is a positive. Meaning of that is your function is increasing on that interval. Function is increasing on that interval. Now we have to check here, that is you can plug in, this is 21.3, so you can plug in 22. Let's see what happened. When x equal to 22, your volume at 22, over here in the parenthesis, you can even write 22, that's the best way. Just give me a second here. I just want to erase this and then write 22 here. So the volume at 22. That is equal to, let's plug in, so negative 6 times 22 squared this time, plus 128 multiplied to 22. So if you simplify this, it will be negative 88, which is less than 0 or negative value. That is, the function is decreasing on that interval. Function is increasing on the first interval, decreasing on the second. If you want to draw the situation, it will be like this. It's increasing first, the derivative will be 0 there, and then it is decreasing. So meaning of that is it is increasing, it's going up and then coming down. So you have the maximum value there. Maximum value there. So the value or the volume in this case, okay, the volume of the box or volume of the baggage will be maximum when x equal to 21.3. That's what we need to write. Let me write that down. So volume of the baggage is maximum when x is equal to 21.3. And the unit given in the problem is inches. So I can write 21.3 inches. So when x equal to 64 over 3 or 21.3, the volume will be maximum. Questions, if any? My dear beautiful people, how is math?
I don't think you were recording during that last part.
You're still recording, you didn't stop recording.
Oh my God.